Day, Mrs. Day, Ms.Day, 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 Ms.Day.
Space, the final frontier. We're going to be talking about Sir Isaac Newton, the founder of modern day physics. Sir Isaac Newton was born in Wothrop, England, January 4th, 1643. Now, if you're not aware of Isaac Newton, he was the founder of the 3 Newtonian physics laws. Newton's parents were farmers. But Newton, however, disagreed with the farmer lifestyle and wanted to be more scientific, like me. I'm Neil deGrasse Tyson. He then attended the University of Cambridge, where he developed a strong interest in chemistry and natural sciences and mathematics. Like Neil deGrasse Tyson. That's me. Like Neil deGrasse Tyson. And then, after he spent years at the University of Cambridge doing similar to a work study, Newton became infatuated with the natural phenomena of the universe, like I am now. It's Neil deGrasse Tyson. Soon after the Great Plague infected the University of Cambridge, Newton retired to his own private studies, where then he discovered more about the infinitesimal calculus, the color and light spectrum, and the 3 basic laws of physics that you'll see now in this video featuring the one and only Neil deGrasse Tyson. It is here in his private studies where the legend has it that the apple fell on Newton's head where he discovered gravity, like I'm about to do so now, as Neil deGrasse Tyson. I'm Neil deGrasse Tyson.
E equals MC squared Ms.Day. Calculus and algebra. Complicated mathematics. Oh, this fun math. This apple. It makes me want to discover the 3 laws of motion. For my first law of motion, I'll call it Newton's first law of motion. Law number 1. This is the law of inertia. An object in motion stays in motion.
Unless acted upon by an outside force.
An object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. In orbital mechanics, an object with a constant centripetal motion will continue in that motion unless an outside force, such as a gravitational force, from another object influences it, changing the object's motion.
I'll call this law of motion Newton's second law of motion. Number 2.
Newton's second law will state that an object's force is in relation to its mass times acceleration. For example, if an object is thrown with barely any horizontal acceleration, then the resulting force will be almost insignificant.
Now if you throw it hard,
I'm gonna fight 'em
hard.
A 7-nation army couldn't hold me back.
Hard. That's for 1673. And by hard, I mean with greater acceleration.
The second law states that the acceleration of an object is dependent upon 2 variables, the net force acting upon the object and the mass of the object. For example, when a 1,000 kilogram object with an acceleration of half a meter per second squared, the resultant force will be 500 newtons of force. This simple equation helps scientists predict predestined routes for objects in orbit, as well as a foundation for modern-day physics in identifying parts of the universe.
Number 3!
Newton's third law is, for every action there is an equal and opposite reaction. The statement means that in every interaction there is a pair of forces acting in the two interacting objects. The size of the forces on the first object equals the size of the force on the second object. For example, in orbital mechanics, when the sun pulls on a planet with the force of gravity, the planet pulls on the sun with an equal magnitude. But because the sun is so much more massive than the planet, Newton's second law says that the sun will experience much less acceleration.
Yep.
Newton's third law states, for every action is an equal and opposite reaction. I'll call that Newton's third law. As you can see, the apple fell 1 Newton force towards the ground. And the apple isn't through the ground, obviously. That's because the ground exerts 1 normal force, Newton force, up. Therefore, it's equal, and they're balanced.
The normal force is the force an object feels from another object. Now, if you were in a drag race, like I am right now, this is the force I'd be exerting on apples. Take that, apples.
For future applications, Newton can arguably be credited with the first undertaking and approaches for modern quantitative physics. Thus, his future impacts on the future will be incalculable, whether it be from the discovery of rocketry using two balanced forces in order to propel an object into space and into orbit, or whether to use other gravitational fields of other objects in order to propel objects into space. Newton's contributions to science, especially into orbital mechanics, has been one of the single most significant contributions throughout all scientists.
Neil deGrasse Tyson!
Oh! Hey!